So today what we're going to look at is limits of functions of multiple variables. Now, it's more complicated than taking the limit of a function of a single variable, as you have to account for essentially an infinite number of directions, as you can come at a point from this way, this way, this way, really any way you want on a 2D plane. So you're going to have to be able to account for all of those. Now, you can't account for all of them by evaluating each case separately, as that would go to ad nauseum and you'd never finish. So we need to look at a better way of doing this. And we're going to do this by taking advantage of polar coordinates. Now, in this limit here, as x and y approaches 0, 0 of x plus y to the fourth over x squared plus y squared, it should be obvious that if we try to approach 0, 0 using this, we're going to get 0 over 0. So that's where our polar coordinate transform comes in. So it should be noted that to transform to polar coordinates, x equals r cosine theta, and y is going to equal r sine theta. So we can do a simple substitution here, and we could rewrite the same function as the following. Limit of, I'm going to still use the x comma y here, but x comma y aren't going to appear in the form that I'm going to show. Actually, no, I'm not going to do that. That is a bad idea. That is confusing. What we're going to do is we're just going to plug and we're going to ignore the limit for now. Normally teachers wouldn't like this, but we're going to do it here anyways for simplicity. So I just plugged this x in for r cosine theta, and now I'm going to do r sine theta, and to the fourth. Now this here is going to be r squared cosine squared theta plus r squared sine squared theta. And we can factor out the r squared there, and it's obvious that sine squared theta plus cosine squared theta is 1, so we're just going to have r squared on the bottom here. Now we're going to simplify the top, and we're going to factor out r to the fourth. And that's going to be over r squared. So the r squared and the r to the fourth, you can just use your basic algebraic rules of powers to simplify this entire equation down to r squared cosine theta plus sine theta to the fourth. Now, here's what we're going to do. We're going to make a couple observations about how this function behaves. And first we're going to start by observing r squared. Now, r squared is a continuous function. It's just gonna be a parabola. And whoops, that's not what it looks like on the graph. Yucky. Somewhat closer. Still not that great. But this function here is a continuous function. It's everywhere differentiable, doesn't have any singularities, you never divide by 0 anywhere, and cosine of theta is continuous, and so is sine of theta, and they're both differentiable, continuous, and they don't have any singularities, and so they're smooth. Now, it should be noted that the product of two smooth functions, trigonometric functions and a regular power function, is going to yield another function that is also smooth and continuous, so it doesn't have any singularities or holes or any funny points that are hard to evaluate at. So we can take advantage of this property in polar, and that's going to allow us to ignore the angle theta, because it lets us know that if we draw a region of if we have a circle around, let this point here be 0, 0. If we have a circle around this, and we can put the circle to any radius of this function, so this would be looking top down onto the xy plane here, it lets us know that there are no points where we have discontinuities. So we won't need to account for theta in our evaluations, and we can only need to account for r. So that means that for any theta, as we approach this, we're going to be approaching the same value. Now, that allows us to just evaluate the limit, and we can just do this as the limit as r approaches 0 of r squared cosine theta plus sine theta to the fourth, and this simply equals 0, comma 0 when we transform it to xy coordinates. So it can be noted that the limit of x comma y approaches 0, 0 is equal to 0, 0.